Now, Tin, who knows Moscow Python community, and Moscow Python community knows him. So yeah, thank you so much for your talk at our October event. So now,
thank you.
Well, you are welcome. So let's talk about challenges at kiwi.com. I'll launch presentation in a second. Meanwhile, you can just applause.
Okay, it works. Thank you for the warm welcome, ladies and gentlemen. My name is Tin Markovič, and I'm going to be talking about challenges at kiwi.com. The title, Connecting 100, is a little bit buzzwordy. It's supposed to have multiple meanings. It's supposed to be about us connecting 100 of different flight airlines, different operators, now even ground transport, hundreds of people, connecting them to same bookings, to same travels, hundreds of places in the world, and in the end, hundreds of systems. This talk is going to be about how Kiwi works under the hood. My colleague, friend, Stanislav, has explained some of our continuous integration. I'll explain some of our processes. Who are we? Why do we use Python? What are our daily problems? What are our daily challenges? What do we work with? What are our assets? What's the work we do, problems, and opportunities? I'll try to be relatively brief, but you'll hear. I am a team leader at kiwi.com. I like to meddle with software architecture. I like to make solutions that scale, that work, that are not overly complicated. I try to solve problems as efficiently as possible without throwing masses of spaghetti code at them. I have experiences working with big projects other than Kiwi. I worked with edX and with the Texas University on some knowledge sharing platforms, etc. That's less important today. Where do I feel in the Kiwi picture? I've recently become a team leader. Before that, I've been the main person for splitting services to Mambo and Backoff. I'll get to them later. There are smaller microservices that tear off from the monolith. And yeah, I'm a developer at Kiwi. We are a simple company that Stanley has already introduced. We can be put down to making travel better. We try to make traveling a more pleasant thing, a more enjoyable experience where you don't have to worry about price checking, about finding out which airline does what, some scummy policies. We try to explain everything plain and make your travel experience streamlined and make it just simple, better, and work. Of course, we use Python, otherwise we wouldn't be here. We started with it mostly because of its prototyping power, of it being able to do a minimum viable product in weeks and not months and years, and about being able to release fast and work fast. We began as a startup, as Stanislav explained. We had to adapt, we had to scale quick, we had to try, fail, and learn. That's one of our primary guidelines, that's one of our philosophies, and that's also how we draw parallels to Python. We also rather ask for forgiveness than for permission. That's one of our tenets for developers too. We're supposed to try things to work and not to have big communes of hundreds of people asking and talking about small decisions. That's why we have to have these advanced systems so everybody can work to the best of their ability without stepping on other people's toes. We have some problems with our work, of course. We have an enormous scale. We have a worldwide scope. We have to be available 24/7, every day of the year. Downtime should not exist for us. We need better standards. We have worked a lot. We have advanced a lot. And we have noticed that Python, however good and useful it is not really enforcing standards as much as we'd like. We need to have a more stable environment in the future as it changes often. Stanislav has shown some of the images, some of the end game. We're getting there. And we're trying to get there in nice, comfortable steps. And those are all growing pains of a company the size of Kiwi. It's expected, it happens, and we're trying to overcome it and managing as well. Python has some problems intrinsic to Python. We have problems with type security. MyPy was mentioned. We have problems with too much reliance on dictionaries, which become some kind of a global pattern, global variable, if you abuse them. And we have problems that in our company, with as many developers and focuses as we have, there's usually more than one way to do it, which is not a good thing. We try to tackle all of these problems, and I'll mention how we do it onwards. Some of these problems also come with challenges. One of our primary challenges is the speed of delivery. We need to deliver fast, we need to deliver daily, we need to deliver reliably. There's also the problem of having no acceptance for downtime. Some systems may fail, and then you have a disgruntled customer who will come in 20 minutes and try again. If our system fails for 20 minutes, we have hundreds, sometimes even thousands of unhappy customers who couldn't book their plane, who couldn't book their flight, who couldn't board their plane, who couldn't get their data. So any downtime bigger than a couple of seconds is completely unacceptable. Even seconds are essential. We also have our primary challenge of making travel better, of being more reliable. So a customer can never get stranded at the airport not knowing what their tickets are, not getting their seats in an allocated time, and having other reliability problems. We pretty much try to be a company that a customer can depend on. Python sometimes makes it difficult. We have some assets as well. We have assets that help us deliver this. My colleague Stanley talked about the continuous integration, our source control. We have one of the best setups in the industry. We have very strict checks. We have very thorough checks. We're getting there in the tests department, but we're getting there. We have a process, but we try to keep it measured. As I've said, we try to motivate our developers to try, to review code to each other, to develop things, to not be bogged down by process, management, and other slowness of a corporate environment. We try to keep it indie still. And we try to have as much safety nets as possible. That's pretty core in a business like ours, where we try to have a blameless development, blameless environment, and we have fallbacks in other systems, safety queues, and our customer support that will manage catastrophes to a minimum level. Our static stack is pretty much Pyline, Koala, SonarQube, and MyPy. Black is also there. I didn't mention it. Colleague Stanislav went over most of these. I'll just touch on to MyPy a bit more. It's a big advantage to use static typing, especially with MyPy, which allows you to use it when you need it, because then you can select these pieces of code that are sometimes troublesome and have static checks through MyPy assert that they are not going to get unexpected input. We use it in some places. We don't try to shoehorn it everywhere. We don't try to imitate Java. And it's great when you need these certain amounts, the certain functions to always go deterministically type-wise. We also have a good logging stack, tracing stack, from Sentry to PagerDuty to Datadog to Kibana and its stack. And I mentioned most of these in my talk from Python Conference Moscow. So if you can go and watch that, you can get more details on these. Now, what do I do specifically? I'm known as the bagman in some circles in the company because I've gotten the huge task of refactoring how we look at baggage in Kiwi. We had this somewhat foolish philosophy of looking at baggage as just an integer on a booking. which is incredible when you think about it. A single booking can have dozens of passengers, tens of flights. It can have these complex things, and you put all baggage in a single number. You put 2 bags on 5 passengers flying through 3 flights. And then you have a lot of problems in the future when you have to show them more information, when you have to change those things. And developing something as essential to the system as that, when that system cannot stop, cannot fail, cannot roll back, is somewhat challenging. I'll just say that. It's going well. We're getting to a version 3 of the baggage system today. Thankfully, colleagues are releasing it right now. So that's water under the bridge almost. And I'm also dedicated to some services like Mambo and Backoff, which are funny names we choose for services as MMB and back office. Those are parts of our Manage My Booking system that have been in the monolith, and we're trying to move them away. Our job is quite precise when it can be, but sometimes it's very vague. You've all flied, you've all had problems with flying, probably. There are many issues when you have these small text, tiny text policies that you don't know about, that happen to you, and then you have to shrug your shoulders and say, I didn't read the small print. We fight those on a daily basis, and that's where Python in our stack really shines. It lets you dynamically update things on the run. A recent example is the case with Ukraine banning entry to Russian men. It was revealed in the news less than a week ago, and in some companies, some of our partners even, it will take weeks to remedy that. It will take days and days to fix it in their systems. For us, using Python, using our toolset, it took 45 minutes to release a fix to help warn people about that change and block them from wasting their money. We also enjoy our work because of that, because it has a visible impact. We can watch the dashboards to read our conversion rates, to see the customer satisfaction, to hear daily, weekly, and monthly reports about how much people we make happy. It helps your morale when you have to work on super old code and you know it makes somebody happy. Now to some details. This didn't really work. Okay. We have this huge system called Booking that we work on. We have recently renamed it internally to Monolith because it's the monolith. It has hundreds of thousands, even millions of lines of code. We are trying now to scrape off part by part, which thankfully with Python is relatively easy, as we can inject these new parts, the new services, there where we use the older ones, where we managed to work before. We're trying to go from a method or a function-oriented approach, from an approach where you use an endpoint at your web API to just do something, to a more resource and item-oriented approach, which more aligns with object-oriented programming. A lot of people get scared about these buzzwords, as they call them, because Python doesn't force you to do this. But I'd argue that there are advantages to going a bit Java-like in Python and trying to work with resources, trying to work with objects and classes, rather than winging it and letting hacks save the day. We're also working on our system to make it REST-ish. I'm not going to say REST because we have to do it right, but we also have to mind our business model. As I've said, we focus on trying, seeing if it succeeds, then repeating. We try to have endpoints that would be familiar to everybody who has ever worked with REST, but not as strict to require days and days to develop a single endpoint. For that, we use the library connection, which is a Flask extension. How many of you have ever used Flask? Could you raise your hands? Yeah, a fair number of people. You should try out Connection. It's pretty great. And it lets us use Swagger, or more recently known as OpenAPI, to define our schemata and to make sure that multiple teams that we're splitting our work on can and will cooperate more strictly. If you use the same schema, Swagger and Connection, to validate it, Connection will force you to return proper responses, to return what your schema demands. So I, as a team leader, can set up some schema for the different teams, what my system expects, and they will be internally forced to return those results. So their continuous integration will force them to actually send me what I need, send my applications what I need. And you instantly solve a lot of problems with integration of different microservices. It really solves a lot of problems. And what we require to solve this further, rather than just validating, is to map the process, to map the things that need to be done. We had a lot of problems with rapid growth. Who here is from a startup or a similarly small company that's trying to grow fast? Could you raise your hands? There's not so many people as I've expected, but a fair bit. Sometimes in a startup or in a big company that grew from a startup, knowing what your code should do is hard. It has problems where you don't know how the processes work. You have to read from old code and figure out what does what. That's why we had problems with mapping all these edge cases and fixing them. We had to read our projects from the old code rather than an actual document that describes the process. If you can, focus on eradicating this as much as possible. It's a big issue, and when you focus more on doing it resource-based, a lot of these edge cases you can figure out and probably remove. As your company grows, you can try to bully the edge cases out and try to stop them from happening if you can. Basically, try to remove the hereditary way of writing code where you have to figure out what your predecessor did without any documentation, write the schema. And in the end, we, splitting all these services, we got some take-backs, some summations, some conclusions from that. Pretty much mapping these processes, getting people to figure it out, getting some documentation and schema to invalidate the edge cases, helped us remove them and streamline the code. Then when you have that stronger model, when your system can be mapped into a stronger system, it becomes a lot more reliable. You remove these borderline cases by changing the process or moving it to other modules, and you get a lot of edge cases removed. Important example was that we have a baggage serving server that collects all the dimensions and limitations from different airlines. And we've had some backend logic that also blocked some airlines from buying baggage. And after figuring it out, after writing down the schema, after figuring out that this information is stored on backend, we've been able to remove it, to remove dozens of lines of code that were there creating code depth and making our problems, by just moving it on and not having those bags defined at all when they're not available. Just removing them from the source. And mapping that process helped us come to that simple conclusion. And yes, if you're designing an API tomorrow, try to write it in a resource-oriented way. Don't have an endpoint that says book a flight, but create individual resources. Create a passenger, create a flight, create a booking in the end. And that will scale much better when you later have to create these pieces individually and not in a big operation. Yeah, takebacks from Python are that we had to implement stronger validation, stricter. MyPy helped, especially in combination with Swagger schema, because then you can set down a strict schema and validate that it's right via MyPy, via typing. And we used modules generously. We put all these schema into common modules that any team could implement. So you would just implement Kiwi schema and activate it, and then you have 6 different services all obeying the same rules. And that helped us split this big monolith into many smaller pieces. Thank you for your attention. Any questions?
Thanks. Thanks so much, Tin. Hey, someone asked me for power bank. It was you for second time. Come up here. Yeah, just a second. Sorry for that. Just 1 second, and now you might start asking the question.
Thank you for the speech. It's about it's a little bit philosophical question about Python. Don't you think that using some tools like MyPy, it's putting chains on the developer's hands, and he lost all his freedom about writing the code? But I understand that sometimes it's needs, but it's not about philosophy of Python. It's I don't know, typization, you know.
We require those to put chains when there are more than a single way to do it. When you have multiple developers approach problems differently, and we had recently a relatively sizey argument about whether we should represent prices as floats, doubles, or strings. In the end, when you decide something, adding typing makes you commit to that, makes your team decide that and keep to it, so no stubborn or pretty individual people can break the pattern, and then you have problems because there's more than one way to do it. We just took priority on some principles of Python rather than just dynamic typing. And the schema being validated by types helps a lot when you work with multiple teams. It really speeds up everything, even though it lets you be free less.
Okay, thank you.
Right. Any more questions? We are done with questions. Okay.
Thank you, people, for your attention.
Yep. Okay. Thank you.
I'll be around so you can ask any more questions.